This is Don Larson here again. I think we're ready to get started. So again, welcome to everybody today that has joined us for our webinar on CGM and SVG conversion solutions. The agenda today is going to be my brief introduction, then we'll go through just the housekeeping and procedures for this webinar that we'll be using today. I will give you just a quick company overview for those who are not familiar with Larson software, and then we'll jump into the slide presentation and some technology demos. And then we'll wrap up with a summary and a QA and then closing information. Our procedures today in this is all attendees will be muted for the duration of the webinar. If you should experience any problems though, use the little chat window over to the right. Computer audio is the recommended option for this webinar, but we also have a phone-in number. We also have some product data sheets that we've made available as handouts for you. You can, I've got a little arrow there pointing to the right where you can just drag and drop those PDFs to your desktop, and so they're at your disposal. If you should have any questions, you can post at any time during the webinar using the panel. You don't need to wait to the end to post. Just if you think of something that's being presented, just go ahead and post, and then we will get to it at the end, and then we'll answer those questions following the main presentation. And if we shouldn't be able to get to them all, we'll make sure to follow up with an email. Larson Software was based in Houston, Texas. We were founded in 1984 with a mission to be graphics technology experts. We develop powerful, innovative graphics software and toolkits based on open standards like CGM and SVG and PDF. We promote CGM usage by making a free CGM viewer, CGM and TIFF viewer available. That's available on our for download on our website. We're the developer of the first HTML5 CGM viewer that enables CGM viewing in a browser without a plugin. We're a member of the CGM Open Foundation. Our technology simplifies the graphic workflow for technical publishing professionals, engineers, and those that work with tech data and visual tech data. So with that introduction, I'm going to now turn it over to David Manick for the main part of our presentation.
Thank you, Don, and good morning. Good morning, everybody, or good afternoon. Just to give you a quick warning before we start, I'm recovering from quite a heavy cold, so I'm just hoping my voice holds out for the duration. If it does go a bit quiet, it's probably because I'm just getting a glass of water or something like that, or a sip of water. So thanks, Don, again for that introduction. In this part of the webinar, I just want to go through some background of why we're here today. So in February 2018, we staged our CGM and SVG Workshop. The subject matter had a very kind of high interest, and we wanted to follow that up today with more focus on the technology that we're developing and our strategy for the future. So we'll be demonstrating that technology today. We'll also talk about standardization, which is very key if you're in the world of aerospace and defense and using CGM at the moment. And as I said, we'll be talking about what's our strategy going forward for the products and standardization as well. And as Don mentioned, at the end of the session, you'll be able to post some questions, or you could do it during the session, and then we'll try and answer those at the end of today's webinar. So as I said, the main focus will be on these three topics: demonstrate, standardization, and strategy. So we're going to demonstrate some of the technology that enables you to go, say, from CGM to SVG. But we're still aware of other formats are important as well, like PDF and so forth. We'll talk about standardization and what we're trying to do in that area to make the files that we're creating a standard, and they're good for data exchange or interoperability, that we can move it from one piece of software to another and we're going to get the same result. And also product development. Let me just quit out of this, sorry. Sorry about that. Let's go back. And then we got strategy, so what we're doing forward, product development, and also the standardization of what we're trying to achieve as well, with data exchange, say, between SVG and CGM. So to give you some background to begin with, if you didn't attend the workshop back in February, historically CGM is got a very long history, so I'm not going to delve too much into it here, but it's still being used widely within many markets, including aerospace and defense and automotive and so forth. And there was a web CGM profile that was developed and really for delivering vector graphics for the web. So that was developed, that profile, and has been adopted by different organizations. With SVG, my take on SVG, it was actually developed specifically for delivering high quality vector graphics for the web. So it wasn't really developed as a publishing format, say for to go to paper or whatever. So it was really designed for the web. And like a brief history of it really is that it was a coming together of different companies and organizations who put this together and decided to base this standard on XML. So that organization is active, and there's a link down there if you're interested to get more history on the format. But with CGM, it's a 2D open graphics format, as SVG is. It's not owned, it's non-proprietary. It's managed by CGM Open. It's been around since the 1980s, but it's still valid format. Just because it's been around a long time doesn't make it not valid. It's a W3C standard, so the World Wide Web Consortium. It was delivered and adopted by the S1000D specification, so it's written into their spec. One of the actual downsides, perhaps, for the format has always been when delivering graphics, say, via a browser, as it required a plug-in technology. So you needed an ActiveX control or something of that nature to actually view the graphics within a web browser. And that was always something that companies didn't like because of the fact that it could cause security issues and so forth. So and I think now we're beginning to move away from that paradigm as the web browsers don't support plugins anymore. So CGM, I mentioned where it was used earlier, but just to qualify that, aerospace and defense, automotive, oil and gas. So why these industries? And I think it was specifically because it was a non-proprietary, it was open. So they have more control over the format. And there was also the ability to validate the files and move them around different organizations or into the defense organizations such as the DoD and MOD, and the files would work wherever they went. So that was one of the main reasons for the use of CGM. In oil and gas, it was slightly different. It was mainly used as a data exchange format to get things out of, or graphics out of software and then display them for presentation purposes. So not really publishing as such. It was more about presenting data kind of on the fly for exploration, oil and gas exploration. So a completely really different usage. So things like hotspots and web delivery were not really needed. So SVG, if you're not aware, it's XML encoded format. It's also a W3C standard, so same as CGM. It's managed by an SVG working group. And it has native support in popular browsers like Chrome, Internet Explorer. So you don't need a plugin, basically. You can actually view graphics inside that browser without a plugin. So where is it used at the moment? We did some research into this, and we feel that the main areas it's used in is it's used widely in GIS, or Geographic Information Systems. Not Google Maps, though, we found. They're still using bitmaps. It's used in graphic arts, obviously, because it's built into things like Adobe Illustrator. I'm not sure if this link will work, but it's also used in data visualization. So here we have something where you have the graphic, but it's kind of data driven. So if you see as I move over, the graphic changes. We also get at the top, we get kind of a level of percentages for different products. It's changing in the center as well. So this is one of the things we found. It's used in this data visualization area, but it's also used in, as I said, GIS. So there's some links down here that you could use if you wanted to do some more research into that. But at the moment, not really widely used in technical publications, but we feel that will change. So we're going to look at the technology to begin with. And we have different products in this area. So conversion and editing, and viewing. Excuse me. So convert CGM to vector is the first product we're going to look at. That's available as a desktop version, which we'll look at today, but it's also available as a command line and as an SDK. So you can go from completely just a standalone application to trying to integrate it into a production process with a command line, but also completely integrate it into your own software. So we offer that in a lot of different facets of our conversion technology. The second product is Visx Transform, which we like to think of as our flagship conversion software. It handles multiple formats. There's no SDK, but it's available as a desktop and command line software, and it's Windows only. And then we have Visx Edit, which is our CGM editor, and we'll look at that in the context of this presentation. And then we thought we'd add in a viewing part as well, because we feel that the main reason, for instance, that people are going for SVG at the moment or converting to SVG is to view on the web. So we wanted to give you some context to doing that as well. So the first demo is going to be, these are only short demos, so we can provide you with more personal demos if you need it at some stage, or evaluation software if you want to look at the software. So convert CGM to vector is the first software we'll look at. It's just a basic interface, really. We're just really choosing the files that we want to convert. In this case, I'm going to use the S1000D byte data. These are all CGMs. I've got some options here that I can set. So CGM to vector has three really formats we support. So PDF, EPS, and SVG. We're going to use SVG for this particular demo. I can choose my output location. I can actually append the file name if I need to, so to give it a unique name. We can set the scaling and so forth, and the other things in here. Okay. So what I'm going to do is I'm just going to take this folder, I'm going to drag and drop it into the area down at the bottom, and these are the files that will actually be converted. When I want to start the conversion, I just say convert the selected, and it'll go through the process. So you can see that there's a percentage of the file that's been processed, and it will keep going down. So that was a pretty quick conversion. One thing I didn't show you was probably the option, it's gone into a specific directory here. So I can go to that directory and we can look at that conversion. Another important thing as far as conversion software is concerned is that we have a log of all the files that we've converted. And if there's a particular file that doesn't convert, then the software will actually skip it and carry on with the conversion, which is pretty important. If you're converting thousands of files, you don't want it to trip up at the third one and then the whole process just breaks down and you don't know. You could be running this overnight perhaps. So I'm just going to go to those converted files, so we've got them on here, CGM to vector, and the icon it's just given automatically is like the Chrome icon. So here's the SVG files. This one here has got hotspots on it. So this is the famous CGM, the S1000D bike. But I wanted to show you here that even in the SVG, what we do is when we convert from the CGM, we preserve the hotspot information. So I don't think you can see that on there. I might be able to zoom in slightly. So when I move over, the hotspot is preserved from that original file, which is important if you're going from CGM where you've had hotspotted files before. You don't want to lose that when you go over. And we'll talk about how we write that file out later on. So let's go back to the slide. So CGM Vector it's ideal for processing large CGM graphic archives. It supports not only SVG but EPS and PDF. And PDF is going to be another focus of ours this year as well. When converting files, we're going to do some more work around converting to PDF, because PDF is another open format now, if you weren't aware. We retain that hotspot information, as I've just mentioned. And we have this GUI version, which I've just demonstrated, but we also have the command line, which you can integrate. And this could also be into a system that's based on Linux. So this could be important if it's on a server. Obviously, there's Windows and Linux servers. And then we have the SDK. So you could actually integrate this into your own software. The next product is VisX Transform. So let's just go to VisX Transform. Interface is slightly different. This is again the GUI version. We also have a command line version of this software. I've got the same data here, but we do support other data as well, which we can import. This really handles multiple formats like DWG, DXF, PDF, Adobe Illustrator. So really different formats we support here. So what I'm going to do is I'm going to convert the S1000D bike data again. I'm going to add all to our selected files, and I'm going to convert them into this particular directory here. But before I do that, I'm just going to go back to my settings, because VisX Transform has the ability to automatically hotspot information that comes through it. So this could be like a whole raft of CGM files with no hotspot information, and you just want to hotspot them and then export them back as CGMs with hotspots automatically done. And we have a lot of customers who do that. Rather than manually do it, they do it through an automated, through VisX Transform. So we have different parameters we can set for the hotspot here, like the number of characters and so forth. And we also have the ability to OCR, so you could even hotspot raster images, so old images that have been scanned in. And I'm going to choose my output format. So you can see we could just go from CGM to CGM if we wanted to and hotspot them. Or in this case, we're going to go to SVG. Again, we'll talk about this later, but we're going to have the application structure, and this is the naming convention that will go inside the file. So in this case, it will be an XML file because it's SVG, and we're going to name the application structure hotspot. So there's some consistency in there when we actually export out, so we can find that information within the XML. And we can also append the file name again. Okay, so I'm going to, I think we're set now. I think everything's ready to go. And I'm going to do a conversion of these files. This might just take slightly longer because it's hotspotting them as well, but in this case it's not too bad. There's only 39 files, so you can imagine if you had thousands, obviously, then similar to before, we log everything that goes on, and if it actually finds an error, then it will actually just skip it and go to the next file. So that is complete. before I just show you the converted file, if I go to VisX Edit, which we'll be coming back to later on, there was one particular file here that's in the directory, and the original, you can even download this from the S1000 ePeople, is that this is not hotspotted, this particular illustration. So I just wanted to show you, once the conversion is done, which is now complete, let me go down to the desktop, and we should be able to see VisX Transform. This is the file here. Again, SVG. I'm going to open that up, and you can see here that the file is actually now the hotspots have been added to it. So we've not only taken the CGM and converted it to SVG, we've also hotspotted it at the same time. Okay, so let's go. Sorry, there's some switching about on the software. It's just got a lot of different software we're running all at the same time, so apologies if it doesn't seem that smooth. Okay, VisX Transform. Ideal for processing large raster and vector archives. Raster files, we can add hotspot information via our OCR technology. We can also export out spreadsheets as well. This contains coordinates of hotspots, which can be important to some ITEM or IETP systems, interactive electronic technical manual systems. We can also process 2D CAD data. We have customers who actually take DWG straight from their CAD system through VisX Transform to CGM and hotspot and so forth. We can also convert PDF to CGM or SVG, and convert CGM to SVG, and as we saw, retain hotspot information but also add it at the same time. Excuse me, I'm just going to have a quick sip of water. So, editing graphics. So VisX Edit is our software that we developed as a native CGM editor. So it's crucial that you have to maintain your CGM archive, or bring files in from other systems, convert them to CGM, add hotspots and so forth. VisX Edit, there's also IsoDraw, which is obviously very well known from PTC, but our kind of version is VisX Edit. It doesn't have all the functions of IsoDraw. We don't import 3D CAD data, but we are working hard. It does automatic hotspotting and so forth. So it does have some differences that I think you'll appreciate. SVG, actually opening SVGs, importing SVGs and exporting. There is support in the mass market for things like Adobe Illustrator and CorelDRAW, but what we found is that one SVG to another SVG, exported from different software, won't necessarily work. It's not very interoperable. The spec is very large, and we'll talk about that later. So we found even from one software exporting its SVG and then unable to open its own SVG up. So we still believe CGM is probably the best archive format because of the problems of interoperability. But what we're committed to at Larson is trying to develop a standard SVG which you should be able to read and write. So VisX Edit, this is our next quick demonstration. That was the file that we I was just showing you earlier. And this particular file, I just wanted to quickly show you that we can hotspot this file out. We can add callouts to this file, and with different options down here, so we can put callouts in a rectangle or circle. So we're in VisX Edit now. You can see we have an isometric grid, and so I'm just going to quickly. I didn't want to do that. Let's just start doing from hopefully 1. It doesn't want to do it. And it do it for some reason. But this is an alpha version of of VisX Edit because I want to show you something else later on. So we do have some few glitches with it at the moment, but you can see it does it sequentially. On the right, on the left, it's actually adding the hotspots automatically. We can look at them here. So automatically we're hotspotting it. So we'll explain a bit about what's going on with some of the things at the moment. Not working as expected, but there you go. So I'm going to save this as an SVG. I'm going to put this on the desktop if I can find it easily. So what I wanted to quickly show you here is that we can create an SVG, and again it's hotspotted. So, and you can see here there's no plugin obviously for the SVG files, but on the other hand, the downside is there's also no control. So if you wanted to use SVG as your output, then you're going to have to write some control around it if you wanted to have like zoom in, zoom out, and also you'd have to do some work about activating the hotspots so they link to text and so forth. So let's go back to VisX Edit. Yeah, so I'm using a version here because we're going to show you something brand new later on. So apologies if that doesn't look quite right. Let's go back to our slides. So VisX Edit, it should be easily integrated into existing processes. It's designed for illustrators and writers. Some advanced functionality, data exchange to support multiple formats, import and export. Graphic editing, we have an isometric grid and drawing tools. We have the call out tool, which I just demonstrated, which automatically hotspots. We also have a hotspotting tool embedded into the software where you can manually hotspot and auto hotspot. So if you've already got annotations, then we can auto hotspot them in the software. And it's compliant with S1000D, ATA, and PIP, which is the oil and gas standard. And we think it's cost effective in comparison to other software out there. So finally, in the technology part, we want to look at viewing graphics on the web. As I said earlier on, is that the main reason we feel at the moment that people are adopting our CGM to vector or SVG technology is they want to get rid of plugins and they want to show graphics on the web. So, so the problem, as I said, was CGM. You actually needed a plugin to do that. With SVG, you don't need a plugin. Obviously, you can just view it within different browsing environments. But in some ways, we see that might be an issue as well, because if it doesn't display as expected, who are you going to go to sort out that issue? Because you'd have to go to somebody like Microsoft or Google or Mozilla to say my SVG is not displaying correctly. So what we've done is giving you the option. So we give you the option to export to SVG and use what you want to use in your particular browser environment, or we've got our own VisX View HTML5 technology, which enables you to use your existing CGM. So we give you a two-option approach, really. The one that you can choose what you feel comfortable with. So I'm just going to go to VisX View HTML5. So up to now, you've been viewing things in the web with SVGs, but now we're going to look at viewing CGMs without a plugin. So this is our evaluation page, and we can give anybody access to this. It's fully documented at the API and so forth. But this is a development environment rather than, I was saying, off-the-shelf product. So what I'm going to do here is this. We've got a really simple toolbar. I'm just going to open a CGM that's on my desktop. And this time we're going to go to the exploded view after it's been done correctly. So here we've got a CGM inside a web browser, in this case Chrome, and we're viewing this without a plugin. So as I move over, we can see tooltips. So everything you would expect from a normal browser, if there's tooltips applied. We can zoom in specific areas. We've done a lot of work around the rendering and the quality of the file as you zoom in. We can pan around the illustration and it will refresh pretty quickly. And we can zoom out and we can set it so it goes back to the original size. So this again now is CGM within the web browser. So we've seen SVG, we've now seen CGM within the same environment. No plugin required. So let's just go back to that page. And we've got another example. So all these examples are on the website. So this time we've got something a bit more sophisticated. So now we've got an exploded view, the same one, but then now we've linked it to the text. So we've now got a table with the parts list on. So this is really all done with HTML and also JavaScript. So you can see we move around, or we could highlight there, so it highlights the bearing, and we get the tooltips again. So this is using Visit View HTML5, so the CGM viewer on the web, and also some HTML to create that table. So everything's still possible, but the main thing is we've eliminated that plugin that's required. Okay, so let's go back to our slides. So benefits of Visit View HTML5, full CGM support, so you can preserve your existing files, no need to actually convert them. The rendering is really fast, no plugin, cross-platform support, so Windows, Linux, iOS, Android. Obviously no software installation because there's no plugin. Easily accessible. The toolbar is completely configurable. And we support obviously because it's CGM, S1000D, ATA, and iSpec 2200. So that's the end of the technology part. We went through a lot of it, technology there. Before my voice gives out, I'm just having another sip of water. Because and the last part here now, we're going to talk about standardization. So we've looked a lot about converting files, but it's been very important for many industries to make that conversion as part of a standard. So both SVG and CGM are part of W3C. So they are open and they are being managed. S1000D is a very important component for the aerospace and defense industry, so we need to recognize that when we start converting these files, and also part of that iSpec 2200 as well. CGM is specified for S1000D, and it still is today, and even in the latest spec. So as a deliverable, you will still probably need to deliver, if you're a contractor or another type of organization, CGMs. But if you're going to display, then you probably would have the choice of actually displaying a different format. So we want to give you the option to do either, really. So the SVG specification, it's XML based. It's there's two real versions of it, or there's a subset of the main version, which is called SVG Tiny, which was really designed for phones and tablets. The full specification is enormous. There's so much in there, and there's so much in there that we won't want to use. So you'll see in a moment that CGM graphics or technical illustrations only really need a small percentage of the attributes of the whole spec. So then the dilemma is, how do we actually write out that and just really write out to a standard SVG? We also see version 2 of SVG on the horizon, but we don't really see any impact. Pretty much all the elements that we need for technical illustration are already there. So converting CGM to SVG, so you can see that we've just done like a a chart there that might just give you some idea of the full spec, the tiny, and then what we're using to write out our SVGs. There is a slight overlap between the profiles, and at one point we believed that we could get everything into the tiny profile, but we've since discovered that this is not possible. There's just elements in the full that we can't do without for when we're actually creating SVGs for technical illustrations. So what are the conversion challenges? File size, certainly with SVG, because of it's really an XML file, it's text encoded, so it's not like a binary file like CGM, is the file size is going to be bigger. Don't really see really much way around that, so I think it's something you have to take into account if you're delivering files, that your archive could get bigger. So that's something you need to keep in mind. Raster images, embedded raster images, again, that could be an issue because, and we'll talk about that more, is that there's no support for TIFF within SVG, and that's the main raster format used within CGM. So that could be something you need to consider. Hotspots. There's no real way of actually writing out hotspots in a standard way within SVG, and that's something we're working on. Line styles are always an issue, as are fonts. So, and we've been working hard with customers who have already adopted our technology to get the best possible conversion that we can. And we're also benchmarking our technology as well. So when we export an SVG out, we want obviously a good performance and the look and feel that we're getting through when we're actually looking at a CGM file within a plugin. So as I mentioned before, there is with raster images, there's this mainly the TIFFs within CGM, and there's no real support for in SVG. It doesn't support TIFF, only JPEG and PNG. So that's something to bear in mind, and also file sizes. Hotspots, we're trying to take a standard approach to that, as I mentioned. So writing hotspots in SVG in a standard way. Line styles, we're working hard to do mapping of line styles over, so they look like they do in the CGM file if you were to view them in a CGM plugin. And fonts almost always are an issue. So we're working hard to kind of map those fonts over so they appear to be the same when they're in the SVG file. And standardization is obviously our objective here. So finally, what's our strategy to try and achieve these things? So it really is in two parts. One is the technology itself, and the other is standardization. So we want to update our software to optimize the SVG export, and also we're now looking at import. We want to develop our products, our existing products, but also new products supporting that conversion. Standardization, we're looking to develop some guidelines for the import and export of SVG and publish those guidelines so that everybody has access to them. So we don't want to make it a secret what we're doing, we want to make it open. And also the exchange of data, we want to try and make SVG as interoperable as possible. We don't feel it can be completely interoperable, mainly because it's so vast, the spec, but we're going to try and achieve that as best we can. So now I'm going to quickly go back to that version of VisXedit, because we want to look at, this is why I say it was the alpha version, because we've now got in here open, and we can open SVG files within VisXedit. So this was something we've been working on. Some of our customers have been asking about it, but we also wanted to learn more about the SVG format, and this was a good way of doing it. So I've got an SVG file here of the bike. So we're kind of eating our own lunch here in that we've actually exported this as SVG and reopened it. So we're going to, it's working pretty well at the moment. It is alpha, but you can see here, and this might explain some of the issues I had with hotspots, is that the actual hotspot on here is blocked in. So it's not come through as a boundary or as a color. So we're still working through that. As I said, this is alpha, so we're working hard to go to beta quite soon and then involve some of our customers in a testing phase. So I just wanted to quickly show you that. And then the second part is standardization. And what we've come up with, rather than just call it Larson SVG, we wanted to try and give it a name. And we thought Tech SVG, so it's technical, tech pubs, technical illustration, would be a good name for it. And this is our kind of subset that we were speaking about earlier on of the SVG spec. So why have we done it? I think we quickly realized we needed a standard way of writing SVG files because, as I said, the spec is has a lot of parts to it, but there is no real there's no profiles or schemas or anything to say how you write that file out. So, and each software could be doing it completely differently. So we've done that by really developing the technology itself. So Tech SVG is a subset of the full and the tiny specs. We're going to document this and publish it so it's open for anybody to see it. And it should help by defining the standard method of working with SVG elements. So as I said, we're going to socialize this, we're going to publicize this, so we're not going to be on our own. And we're going to make some further announcements later this year at the S1000E user forum in September. So in summary, we've been at the forefront of CGM technology for many years, and we're going to continue to provide customers with the best possible technology for any file format, not just CGM and SVG. We do feel like we're leading the way in the technical illustration market with our support of SVG, and we will employ lessons learned really from what we're working with customers and in creating some really good filters, conversions, filters for our customers. We've developed our first SVG import capability you've just seen, and again we're using that in a standard way and using our Tech SVG profile to actually do that. And we'll be pleased to work with any companies or organizations interested in these formats. So thank you for your attention today. My voice is just about held out. And I've got we've got a Q&A session. So, and we've got some questions up here. I think Don's going to rejoin me at this point. And yeah. I don't know if you see those questions, Don. I don't know if you want to say anything.
Yes, I do. I see the questions here. The first one is, and it's pertaining to the segment we did on the BizX transform and hotspotting, and says, can the hotspotting include outline text? And by that, I assume that's you're referring to text that's stroked out or made up of vectors rather than actual fonts. And the answer to that is yes, it can actually, in the transform, if it can't recognize any text in a vector drawing, it'll employ some OCR to try and recognize the text too. So the answer to that is yes. Moving on, the next question, what about SVG Z? Z is in Z compress, SVG compress. And I guess the question there is, what is that impact does that have on file size of SVG? And yeah, SVG Z is just a zip compressed SVG, and browsers support that, of course. And so yeah, that will help some, but it's but of course CGM supports CGM Z also, so CGMs can be compressed. So, but SVG Z will compress them.
Don, I suppose is the question probably around do we support SVG Z?
Yeah, technically, let's see, at the moment not, but it's a relatively easy thing to get around because you just use there's a utility called gunzip that'll unzip them and explode them back to regular human readable SVG files. But currently in the VisX edit, no, it doesn't. But that would be a pretty trivial thing, and I'm sure we'll add that.
Yeah, I think the guy who asked the question, or the person who asked the question, just said the reason he asked is he got 30 megabyte files in SVG, which is quite hefty.
Yeah, that's hefty, and there's a lot of things you can do. It may be, I assume, I'm not sure what the origin of that SVG is, but there are things you can do, of course, inside SVG in the authoring software to do them in a more efficient way.
Yeah, and we're happy to work with anybody who wants to work with us on this. You know, if you want to send us files, or if you want to test the software, you know, evaluate it, and you know, we're quite happy to help you with that
Sure.
project.
Yeah, sure, absolutely. We'd love to. The more challenges we get, because like I say, we're learning a lot about SVG, and there's ways you can make it more efficient. Like if you're putting some embedded raster, which CGM can have embedded raster, and it's critical that the software that convert it use the most efficient method to re-encode it in SVG. So that's just one place I know right off where there can be things that can be done to reduce the SVG size.
Okay, I don't quite understand the next question. The advantage is just network. I don't quite understand that. Any thoughts, though?
Yeah, I guess the advantage, the SVG advantage, I guess, yeah, yeah, the obvious benefit of CGM of FCG is that you can display in a web browser, you know, over networks, you know, easily. So I guess that's the question there. Maybe, I don't know. There's a kind of a follow-up question on that. SVG would be network only was the question. Okay, yeah, I guess, yeah, so SVG Z now would work nicely in a network environment. You could have files on the server in SVG Z, for instance, and your browser is going to automatically accept them and explode them and render them.
Okay. Another question here is we have a large amount, 100,000 CGMs. Will they convert correctly to, I'm assuming, to SVG? That's where we'd probably work with you to do some conversions to test that out. So our answer would be yes, but we'd obviously need to test those to make sure that does work correctly. And that's pretty much what we do with a lot of our customers is we work with them, or we provide them with evaluation software so they can test it themselves.
Yeah, and there's another question here too about ATA 2.4 GR Exchange CGMs. In other words, CGMs that were written according to the ATA 2.4 spec, which is a version 4 spec for CGM. Yes, they will convert through our converter, right? Yeah, now there may be there's some things in some of the metadata that were kind of there for authoring tools. I'm not sure how they'd convert, but essentially they'll convert pretty nicely to SVG.
Good. I've got one here, Don. Tech SVG, is it sanctioned by any organization?
No, it's at the moment, that's a concept that we've come up with to address the need of interchange or interoperability for SVG. And at the moment it's not, but we'll be sharing that. And so we've had a history in working with the CGM standard and making it an S1000D standard. I participated in that working group to develop the web CGM, and so obviously we'd be seeking to do that with the Tech SVG, making it a profile also.
And finally, this is more of a. I think we've shown today that you could use either. You know, stay with CGM or convert. So, what format would you advise, Don, from your obviously vast experience, longer experience with both formats? Is there anything, any advice you would give to companies or organizations?
Well, the obvious difference is that SVG is clearly primarily for display. In other words, it's the language for displaying graphics in browsers, whereas CGM is a good archiving and exchange. It's been around, it's been tested, and so it's very good at exchange, whereas SVG is good at display. So that's the obvious, advantage there of SVG and differences. In other words, something that differentiates it, that's just becoming more and more obvious to me as we work with it. It's that SVG exchange is really not, that wasn't in mind when it was developed either. It was really developed by the W3C, which was a standards organization whose mission is develop web standards. So there was no thought about, or I shouldn't say there was no thought about it, but there's no obvious commitment to exchange.
Yeah.
So we want to fill that gap here with something like Tech SVG and still leverage the power of SVG, but yet, address a need, a standardization need.
Okay, while you were talking, we just got another question, and this is like in my kind of history of working in this industry. It's the one that somebody's asked me 1,000 times. Is any proposed development for tracing raster images to vector? And it's certainly, to my knowledge, Don, unless you've got a secret kind of skunk work somewhere that's doing it in the background. Tracing, we're not really doing an image tracer. It's so fraught with quality of scans and so forth. And I don't know what your take on it is, but that's why really that the CGM embeds kind of raster images in to maintain the original. But I don't know what you think on that.
Yeah, no, yeah, exactly. We've looked at that, and it's a nice concept, but I think it's been, like you said, it's just fraught with pitfalls, and so it's nothing planned on our part on that.
Okay. Okay, thanks, Don. Thank you all for the questions. Very good session for us. So just to close out the webinar today, I said thank you for your time again. Thankfully my voice is held out just. You can discover more information about Larson at our website, obviously. We've got a new domain as well, svglarson.com. So we've got 2 domains now. A link to the recording of the webinar will be sent via email. And all the materials will be available on our SlideShare site. That will be probably tomorrow. You can follow us on Twitter, and also you could actually meet us next week, or meet me, if you fancy a trip to Oklahoma. A bit short notice, but we're actually taking part in the AIA Technical Publications Workshop now. You can contact us via email, obviously, or by phone. And again, thank you for attending today. We'll speak to you soon. Thank you.